All right, ladies and gentlemen, this screencast is about significant figures. And significant figures convey the precision of a measuring tool. So as a review, accuracy is how close a value is to the true value, the actual value. And accuracy can be improved by selecting a tool that has a finer calibration. Precision is how close repeated values are to one another, and it definitely reflects the calibration of the measuring tool. Both accuracy and precision are based on the competence of the experimenter. So let's look at these examples, these visual examples of accuracy and precision. Target number A shows that here's the bullseye. However, none of the arrows appear to have hit the bullseye, and they're sprinkled randomly around. So for A, the results are neither accurate nor precise. For B, however, the results are not accurate because there are no arrows that landed on the bullseye. However, it's very precise because all six of these marks show that they landed in about the same spot. So B shows high precision and low accuracy. C, however, shows a fairly high accuracy because the average position of all of these, if you paired these two, it would be on the bullseye. If you paired those two, it would be on the bullseye. So these are accurate based on the average. However, they're not precise because they're scattered all over the place. So this is relatively high accuracy or average accuracy, but low precision. D shows high precision and high accuracy since the arrow has hit the bullseye and it has hit the bullseye multiple times. Okay, if we look at this, remember that the calibration of the tool affects the readings, so a finer calibration means more significant figures. When we're dealing with significant figures, the big thing is to know whether or not to count zeros. So that's part of what these rules will tell us about. So here's some basics for the first part of your notes. Sig fig is the nickname. It's short for significant figures. And significant figures are the number of digits that matter, the number of digits that actually count in a number. And the trick to handling significant figures is knowing when to count the zeros and when those zeros should be ignored. So here's our first rule. So rule number 1, all non-zeros are significant. So non-zeros would be 1, 2, 3, 4, 5, 6, 7, 8, or 9. Those are the digits that would be non-zeros. So this value, this 7 all by itself, is one significant figure. This value of 385 is 3 significant figures. 41,999 is 5 significant figures. And 18.9788 is 6 significant figures. So in these cases, all of these values, all of the digits count since they are not zeros. What about zeros that are sandwiched inside of a number? So zeros that are significant if they're between non-zeros. So you do count zeros when they're sandwiched inside non-zeros. So 709, this has 3 significant figures because this 0 inside counts. 3085 has 4 significant figures. 410,990.09, this has 8 significant figures. All 3 of these zeros that are sandwiched inside count. And this last value has only 2 non-zero digits at the beginning and the end, with 4 zeros sandwiched inside, so this one has 6 significant figures. Rule 2, all zeros sandwiched inside of non-zeros count. Okay, rule number 3. Zeros are significant if they're on the right-hand side of a number and there is a decimal point. So both of those things have to be present. So zeros are significant if they're on the right-hand side of the number and there is a decimal point. So this value, 70 decimal point, has two significant figures. If there were no decimal point right here, this would be one significant figure. But since there's a decimal point right there, then this is two sig figs. 38,500, this is five significant figures. These zeros all count since there is a decimal point. 41,999,000 is eight significant figures. These zeros all count. Zeros are not significant if they're on the left, even if there is a decimal point. So this value of 0.7, this leading zero doesn't count. So this is one significant figure. In this case, there's only three significant figures. Only the 385 counts. These leading zeros don't count. Here, there are only five significant figures. These non-zeros on the end. None of these leading zeros count. And this shows four significant figures. This zero at the front doesn't count. Let's back up. There's one thing I want to point out about Rule 3 that isn't shown by these examples. I probably should have another example on here that could be like 70.0. If we had another zero behind this decimal point, it's a zero that's on the right of the number and there's a decimal point. So 70.0 would have three significant digits. So if there's zeros that are on if you think of them as being on the back of the number, if there's a significant, if there's a decimal point, then zeros that string out here and are indicate a value less than 1, then those are significant. So that should have been an example that I gave you. Okay, we went through this one. So Rule 4. All right, so go to the practice site, go to our website, tonkadensity.weebly.com, and find the key of flashcards that you need to complete this assignment. You have to look at the flashcard to get a number. You have to guess what the significant figures are in that number, and then flip the card over and see whether or not you were right. So good luck. Make sure that you do a nice job at this, because we have to be able to evaluate significant figures in individual numbers before we can go on to the next step and try multiplying and dividing values and determining the significant figures in an answer. So do a good job.